Pre-statistics. Modeling with square root functions. Lesson objectives. Find an equation of a square root curve that contains two given points. Find the equation of a square root model. Lesson objective. Example 1. Find an equation of a square root curve with the form y equals a times the square root of x plus b that contains the points 2, 3 and 5, 7. Solution. We're given 2 points. We have 2 x values, 2 and 5, 2 y values, 3 and 7. We will use those points to make two equations because we need to find the value of a and the value of b. If you have two variables, you will need two equations. So for the first one, when x is 2, y is 3, so we have the equation 3 equals a times the square root of 2 plus b. The second equation is 7 equals a times the square root of 5 plus b. Approximating the square root of 2, we have 1.41 times a plus b equals 3 from the first equation. And in the second equation, the square root of 5, which is approximately 2.24 times a plus b, and that equals 7. So to solve this system, it's probably going to be easiest to do elimination. So I'm going to take the first equation and multiply everything by a -1. This way, when we add up the b's, we'll have a negative b plus a positive b. The b's will cancel. So the first equation multiplied by -1 is this third equation. So we're going to take equation 2 plus equation 3 and solve for a. The b's cancel. So we have 0.83a equals 4. Solving for a, we divide by 0.83, and approximating it to 2 decimal places, we have 4.82. Now we need to find b. So we pick one of the equations. I'm going to use this one. Y is 3. Here's our value of a. We have the square root of 2 plus b. So solving for b, we need to get rid of this number, and since it's adding the b, we subtract it. So we have 3 minus 4.82 times the square root of 2. And using our calculator to evaluate this expression, we have b is approximately equal to a -3.82. So the equation is f of x equals 4.82 times the square root of x minus 3.82. We can verify this using the graphing calculator, putting the equation in y1 and double checking that our 2 points are close to this curve. Process. To find an equation of a square root curve that contains two given points. Number 1, we obtain a system of two linear equations and two variables by substituting the coordinates of both points into the general equation y equals a times the square root of x plus b. Number 2, we solve that system we found in step 1. Number 3, we substitute the values of a and b that you found in step 2 into the equation y equals a times square root of x plus b. Property. The graph of an equation of the form y equals a times square root of x plus b has a y-intercept of 0b. So if we know the y-intercept, we know the value of b, then we only need one equation, and we'll only need one other point. Example 2. Find the equation of the square root curve that contains the points 0, 5 and 6, 19. Because this is 0, 5, that means b is 5, and our y-intercept is 5. So we already have one of the variables. Now we need to find a, and we're going to use this point. So we have y equals a times square root of x plus 5. Substituting in the values of x and the values of y, we have this equation. Next, we subtract 5 and we get 14 equals a times the square root of 6. Next, we want to divide by square root of 6. And approximating 14 divided by square root of 6, we get 5.72. So our equation is f of x equals 5.72 times the square root of x plus 5. We can use the graphing calculator to verify. We can use the table feature, and we see that when x is 6, y is close to 19, it's 19.01. Now it's not going to be exact because we are rounding to 2 decimal places for the value of a. Here's our graph, and we see 0.5 is on the graph and 6.19 is very close. Lesson objective. Example 3. The number of U.S. Coastal Guard drug arrests are shown in the table for various years. Let f of t be the number of U.S. Coast Guard drug arrests in the year that is t years since 2000. Find the equation of f. So our first step is to compute the values of t. So in this case, t will be 1, 2, 3, 4, and 5. That's our independent variable. This is our dependent variable. And let's put this in list 1 and list 2 and construct a scatter plot. So we see this does look like a square root graph. Now we want to pick 2 points. I'm going to pick the second point and the fourth point. You may pick the first point and the second, and your equation might be a little bit different than mine, but the answer should be close. So for the second point, when t is 2, the number of arrests is 207. And for the fourth point, when t is 4, we have the number of arrests is 326. Next, we want to approximate square root of 2, and we know that square root of 4 is 2. So now we have our first equation, 1.41a plus b equals 207. The second equation is 2a plus b equals 326. Now we multiply both sides. I'm going to use the first equation again by -1. And we have a negative 1.41a minus b equals a negative 207. Make sure you multiply every single term by -1. Then we're going to add equation 3 and equation 2. The b's will cancel. We're left with 0.59a equals 119. Divide by 0.59, and a is approximately equal to 201.69. Plugging this value in for a, and then using the 0.4326, we have this equation. Next, we can compute this value, so this will be 2 times 202.69, and we get 403.38. Then we want to subtract that to both sides, and we get b as a negative 77.38. So our function is f of t equals 201.69 times the square root of t minus 77.38. Looking at this graphically, here we have the square root model, here we have a quadratic model. Now it looks like both these are doing a very good job of modeling the data. But if we were to zoom out, we would see the quadratic would increase until it hits its maximum and then start decreasing, and eventually the y value will become 0. Now if you think about it in the terms of this problem, that doesn't make sense, because likely as time goes on, the arrests are probably going to keep on increasing, but they're definitely not going to ever become a time where there'll be 0 arrests. So the square root model is probably the best one to use in this situation. Process. To find an equation of a square root model given some data. Number 1, create a scattergram of the data. Number 2, imagine the square root curve that comes close to the data points and choose 2 points, and they don't have to be data points, that lie on or close to the square root curve. Then use those 2 points to find the equation of the square root curve. And number 4, use a graphing calculator to verify that the graph of the equation comes close to the points, and does that model make sense in the terms of the situation. Thanks for watching.